Assalamu alaikum. Hello everyone. This is Noman Iqbal here and welcome to my new lecture. Today we will talk about the linear regression. First of all, what is a regression? Regression is a method which we use for estimating the unknown values of a variable corresponding the known value in other value. For example, we are have given some data points and according to of two variables, and according to those data points we have it is given to us to find out the relation or make a model between both variables, so we can at desired value, if we want to change the value of one variable, so according to the changing of that variable we can get the value, desired value for the other variable. So that's how the regression is used or work. So by means of linear regression is that it should be linear, it should have linear variables in the in the model. So it is this linear regression can only work for linear variables, or like a straight line. To elaborate more about linear regression, take a look on this picture. This is a sketch of y and x and y, and we can behold that there are many data points here. So they are showing that there are a lot of data points on this graph and a line is passing through it. So this is how it looks like a linear line. And if we want to find the regression of these data points and line passing through it, so this is known as the linear regression. So as we know that the equation of the line is y is equal to mx plus c, so similarly, by assuming that concept in mind, we are going to the general linear regression model is somehow similar to that y bar equals to a1 x bar plus a naught, where y bar and x bar, a1 and a1 naught are defined by some other formulas known as where y bar equals to summation of y over n. Summation of y means the total number of y in a data point, the data we have given. For example, in the above in this figure, if there are 1, 2, 3, 4, 5, 6, 7, 8, 8 and 9 data points, then there should have the 9 values for the y. So the summation of y means all the values, summation of all the values plus n, that n represents the number of data points. So y, there are 9 y's, so that n equals to y. Similarly, x bar equals to summation of x values of x's upon n number of x's. And the a1 is described as n multiplied by summation of xy minus summation of x into summation of y over n summation of x square minus summation of x whole square. And a2 equals to the y bar minus a1 x bar. So this is the general formula, and the formula is of a1, a2 and y bar yx. So let's do an example to completely understand that topic. So while coming on an example, let's say that we have an example here of a mouse trap. That we have a mouse trap. This is a spring, and with the spring arm is connected, and we have it is given that how much torque is required to open the this torque, how much torque is required to open the arm up to a certain theta. So we have given some data points and relation between torque and theta, and some data points. So by using these data points we have to form a model so that at the desired theta we can have the value of torque. So let's do the solution of this problem. but by the general formula of regression, we know that it's t equals to k1 plus k2 k theta, where k can be here k equals to n summation of for I equals to 1 to n theta I ti minus summation of theta I into summation of gi over n summation of theta I theta square minus summation of theta whole square, where in the data we have given the number of n equals to 5. There are 5 data points here, so n equals to 5. By using that n is equals to 5, we have theta I summation of theta I from 1 to 5, that's 0.7, 0.96 plus 1.13 plus 1.57 plus 1.92. We have summation of theta I equals to 6.28. Similarly, summation of ti equals to 1.19. Then we have summation of theta I into ti. So the theta equals to zero point 0.7 into t equals to 0.19 at 1 point, plus at second stage theta equals to 0.96 and t equals to 0.29, and so on we will do until our last data point, that's 1.92 into 0.31. So the theta I ti equals to 1.5822. While moving forward, we have theta squared. So summation of theta squared, we will do like 0.7 square plus 0.96 square plus so on up to 1.92 squared, and the answer is 8.8398. Similarly, summation of I equals to here it should be here it is this one summation of theta I equals whole square, so I have forget to write here, so it should be here theta I whole square, so that's equal to 39.4384. So by now putting all the values in k2, we get that 5 into 1.822 minus 6.28 into 1.19, 5 into 8.8398 minus 6.28 whole square, and k2 equals to 0.09196 newton into meter over radian per radian. So this is unit. So now k1 equals to t bar minus k2 theta bar. So t bar equals to summation of t over n, that's equals to 1.19 over 5 and equals to 0.238. Similarly, theta bar equals to 1.256. So k1 equals to 2.38 minus 0.09196 into 1.256, then k1 equals to 0.1224 newton into meter. So the torque equals to k1 and k2. By using putting the value of k1 k2, we get that the torque equals to 0.1224 plus 0.9196 theta. This is a linear regression model for mouse trap. So now we can have our theta, we have our torque at our desired theta by using this model or this formula. So this is how linear regression works. Hope this video helps you a lot. Thank you for watching. Allah Hafiz.